Hi, everybody. I hope you're all doing well. Welcome to Network Tech Zone. My name is Sanjana. In this video, we will configure OSPF. The full form for OSPF is Open Shortest Path First. It is an interior gateway protocol, which we also called as IGP, and it helps in better bandwidth utilization, and it is commonly used in large enterprise network. The OSPF is a link state routing protocol which provides faster convergence and excellent scalability. So OSPF is very efficient in its use of network bandwidth. The AD value for OSPF is 110. In this lab, I have taken 4 routers, out of which I have router 1 as my area border router between the area 0 and the area 1. And within the area 0, I got router 3 and the router 1 with network address 10.1.1.0 with /24, out of which I have already assigned 1.1 on this interface on the router 3 and 1.2 on the router 1. I have also taken router 2, and the network between the router 3 and router 2 is 192.168.1.0 with the /24, out of which I have already assigned 1.1 for this interface on the router 3 and 1.2 for the router 2 interface. And between the router 2 and the router 1, I have network 40.1.1.0 with /24, out of which I have already pre-configured 1.1 on this router 1 for this board, and I have got 1.2 on the router 2. So this the 3 routers over here that you see, the 3 networks. So this will be in area 0, which is also called as a backbone area. And between area 1, which is my area border router, in short ABR, I have taken network 20.1.1.0 with /24, out of which 1.1 is assigned on this interface, which is connected on the routers 1, and 20.1.1.2 with /24 assigned on this serial port for 0/2/0 on the router 4. And this will be our area 1. So we will configure OSPF to ensure we are having reachability between these routers. And we will also try to verify the load balancing functionality within this configuration by shutting down one of the links to make sure the traffic will be flowing to another link to reach router 4. Now we will go ahead and configure OSPF, because all this network which you see are in a different network. So we will be able to reach from router 3 to router 1, but you cannot reach router 4 from router 3. If you want to verify, you can just check. I'm on a router 3 being 20.1.1.2. You can see there is a drop of packets. That's because we do not have any routing protocols in place. But if you're trying to reach router 1, that should work. For example, from the router 3, you will be able to reach 10.1.1.2 because it's in the same network. So you can see there is loss of packet. So show IP protocol, you will see there is no protocols running at the moment. Even if you give show IP route, you can only see the directly connected routes and the logically connected routes. Okay, so we will go ahead and configure OSPF. So between this area 0 and area 1, and we will configure first the OSPF on the routers present in the area 0. So I'll go to the router 3, which is this router here, and let's just rename it. Configure terminal host name. Host name router 3. Okay, And the interface I have is 0030. The IP address is 10.1. Okay, sorry, we have already assigned the IP address. So we need to configure just the OSPF, right? So show IP interface brief. You can see the IPs have been already assigned. And it's the status is up. Okay, so let's just configure OSPF. So configure terminal, router, OSPF. The router OSPF, and I will take a process ID, which is number 1, and I have to advertise the directly connected network over here. So at this time, I have 2 directly connected network, which is 10 series and 192 series, connected on the router 3. So let's advertise the same. So it is 10.1.1.0 network with a wildcard mask for /24 0.0.0.255. And we have to specify the area, and this is an area 0, which is the backbone area. And we also need to configure another network, which is 192.168.1.0 with /24 wildcard mask. And the area is 0. Okay. Exit. So that's about the configuration of OSPF. It's very simple. If you want to check it, so you can use show run. And there it is. Okay. So we have configured OSPF on this router 3. Let's configure OSPF on the router 2. We are on router 2. Let's rename this. Okay, it's already renamed. And now we will go ahead and configure OSPF. If you want to just check if there was any protocol, show IP protocols. You will see there is no protocols running at this time. So there is no neighborship. So once we configure OSPF, you will have the formation of neighborship. And let's configure OSPF, configure terminal, router OSPF, the process ID is 1. And here I have 2 directly connected network, which is 192 series and 40 series. So network 192.168.1.0 and the wildcard mask for /24 with the area 1. Oh, sorry, it is area 0, right? Because it's a backbone area. Okay, and we have one more network, which is 40 series. So network 40.1.1.0, already there is neighborship formation. So, okay, so network 40.1.1.0 with the wildcard mask 0.0.255. And the area is area 0, which is the backbone area again. Okay, so now that we have advertised the neighbors for both 192 and 40 network, let's move to configure area border router. Here, this router is going to consist both the area 0 and area 1. So we need to carefully advertise the network on the router 1, which is the area border router. So I'll just go to the router 1 and rename it as the area border router ABR, configure terminal, hostname ABR, okay? And router OSPF with the process ID, I'll still take process ID is 1 here. And here you can see there are 3 networks, it's 10 series, 40 series, and 20 series. So let's advertise all the 3 networks. So the 10 series is again lying in the area 0. So 10.1.1.0 wildcard mask for /24. And we got area 0. We have one more network in area 0, which is 40.1.1.0 network. Let's advertise it. So network 40.1.1.0 0.0.0.255 with area is again 0. But here, this network over here with 20 series is in the area 1. So we need to make sure that you advertise 20 series network for the area 1. So network 20.1.1.0 and 0.0.0.255 for area 1. Okay, so that's configured. So you can verify with the command show run. You can see the 3 networks advertised for the ABR. Okay, so now we will move to router 4 and configure OSPF. On router 4, let's configure OSPF. Router OSPF, we will take process ID 2 here. And we just have only one network connected. So that is network 20.1.1.0 wildcard mask /24. And the area here is area 1. That is what we will enter here. Okay, and exit out. Let's make sure that we have OSPF configured on all the routers. I'll just go to router 3 and say show run. Now I can see the 2 directly connected network, 10 series and 192 series. On this router, router 2, enable show run. We should be seeing 40 series and 192 series, and that's correct. Okay, and on router 4, we can check the show run, and we should be seeing just the 20 series network just there for area 1. And for the area border router, we should be able to see 3 network. So show run. And there we go. You can see 2 networks in the area 0 and the 20 series for the area 1. Okay, so now that we have configured OSPF, I'm going to try to reach the router 4 present in the area 1 to check if there is a connectivity from my router 3. So on the router 3, so I'm on a router 3, so the IP address that you see for the router 4 is 20.1.1.2. So 20.1.1.2. You can see we are able to reach the router 3 present in the area 1 from the router, the router 4 present in the area 1 from the router 3, which is present in the area 0. And let us also check the tracer to see which path it is actually taking to reach this 20.1.1.2. So it's going via 10 series and the 20 series, which is this path. It's going via the shortest path. What if I shut this port? I'm going to try to shut the serial port for 030. So we can verify if it is taking another alternate path. So configure terminal, interface serial 0/3/0, and we will shut this down. Okay, so now that we have shut down this network, you can still reach the router 4 from the router 3 via 192 series, then 40 series, and then 20 series. So let's just try to ping the same thing. I'll just use the same command, copy, and then paste it. So we're trying to reach the router 4 present in the area 1. So here you can see we are still able to reach the router 3. I'm sorry, the router 4. Okay, so the router 4 is still reachable from the area 0. So let us try to do a tracer. So tracer 20.1.1.2, and let us see which path it's taking. So it's going via 192, 40, and then 20 network. So that way we will be able to see the convergence, though there is disconnect in the circuit. So hence, the OSPF is a link state routing protocol for providing fast convergence. And if you want to just check the status, you can use show IP OSPF neighbors. So that's going to show you the dead time, and it will also show the neighbor IP address. So the neighbor ID is nothing but the highest IP address. So the first preference will be given to the loopback. So in case the loopback is absent, then it will choose the physical, the highest physical IP address on the port on the router. So that's the router ID. Okay, so let's just turn this back on, and it will again choose the shortest path. So configure terminal interface serial 0/3/0. I'll unshut it. No shut. It's turned on now. So we have this back on, and then now that it's trying to change from loading to full, show IP OSPF neighbor, you can see the status is full. Here you do not see the DR and BDR status because I've taken a serial link. So this is a point-to-point link. And in point-to-point link, you will not be seeing the status for DR and BDR. Okay, and hence you see the status is full. So that's about the configuration of OSPF. I hope that this video has been informative to you all. Please don't forget to like and subscribe. Thank you for watching, and see you in the next video.